So today we are finding the areas of sectors, segments, and annuluses. So let's start with sectors. The sector of a circle is the region between two radii and an arc of the circle. So here's a circle, here's my two radii, and notice the region between the two radii and the edge of that circle is the sector. It's basically like a slice of pie or a slice of pizza. All right? So you can imagine this as a fraction of the whole circle. So to find the area of a sector, what you're going to do is figure out what fraction of the circle you're working with, and then multiply that by the area of the circle. Now, usually you'll be given this angle right inside here or this arc measure out here. All right? So to find the fraction of the circle, you're going to take that angle and put it over 360 degrees because there's 360 degrees inside of a circle. All right? And there's your fraction. And then, of course, the area of a whole circle is just pi r squared. All right? So let's do an example so you can see this in action. All right. So in this example, you see that the radius is 20 centimeters and this angle in here is 45 degrees. So to find the area, what we're going to do is we're going to take that angle 45 out of 360 degrees because that's what fraction of the whole circle we're looking at. And we're going to multiply that by the area of the whole circle, which is pi times 20 squared. There we go, squared, not degrees. All right, so now let's simplify this a bit. Okay, 45 over 360 reduces to 1/8. So this is really 1/8 times pi times 20 squared is 400. Or simplifying this even more, 1/8 of 400 is 50. So this is 50 pi centimeters squared. There's your exact answer in terms of pi. All right. Now, if you want an approximate answer, put 50 times pi in your calculator. You end up getting about 157.1 centimeters squared. All right. So there's your two possible answers there. All right. But that's this area of a circle, a sector of a circle. And so you'll notice it's not super complicated. But let's get into something a little bit harder, which is an annulus. All right, the annulus of a circle is the region between two concentric circles. So you can imagine like this is a ring, all right? And we're trying to find the area of that ring there. Now, to find that area, what we're going to do is find the area of this big circle, the whole circle, and subtract off the area of the inside circle, the smaller circle. And what you'll be left with is a space in between. So you can imagine that your formula for this would be the area of the big circle, which is pi times the big circle's radius squared. And then you're going to subtract off the area of the small circle, which is pi times the radius of the small circle squared. Okay? So let's do an example so you can see this one in action. We've got an annulus here. Notice the radius of the small circle is 3 centimeters. And it gives you the diameter of the big circle, which is 16, which means the radius of the big circle is 8 centimeters. All right, so let's figure this out. The area of the annulus for here is the area of the big circle is pi times 8 squared minus the area of the small circle, which is pi times 3 squared. Okay, well, 8 squared is 64, so this is just 64 pi. 3 squared is 9, so this is just 9 pi. And notice, we can simplify this. 64 pi minus 9 pi, that's 55 pi centimeters squared. There's my exact answer in terms of pi. And if you want an approximate answer, put that into your calculator using the pi button on your calculator. We end up getting about 172.8 centimeters squared. All right, so there's your two possible answers for the area of your annulus. All right, so let's do a slightly harder one now. Here we go. Segments of a circle. Now, when we talk about a segment of a circle, what we're talking about is the region between a chord and an arc of the circle. So you can see this is a chord, a line segment that connects two edges of your circle but does not go through the center. So there's your chord, and then there's the edge, and so we're looking for that space in between. All right, I couldn't think of an analogy for what that shape looks like. It's kind of just like the edge of a circle, I guess you can kind of say. All right, but the whole strategy for finding the area of a segment is to imagine from the center connecting up to the edges of that chord. Okay, because if you do that, you can almost see that this is a sector of a circle. All right, so if we can find the area of that sector, that whole sector, and then subtract off this triangle up here, you'll be left with the shaded region. Okay, so that's going to be our strategy. And depending on what information you're given, finding the area of that triangle is, well, you're going to have to be a little flexible with that. Okay, I'll give you an example of one. Here we go. Here is a segment we're trying to find the area of. Notice the radius of the circle is 6 centimeters. And notice they give us the inside angle here is 90 degrees. Okay, so what we're going to do is find the area of the sector first. Okay, since we know this is 90 degrees, that means 90 over 360 degrees is what fraction of the whole circle we're working with for this sector. Okay? Times the area of the whole circle, which is pi times 6 squared. Pi times the radius squared. Okay? Now, we're going to subtract off the area of this triangle. Now, because this is a right angle, we know that base times height divided by 2 will get me the area of this triangle. And since this is the radius here and this is the radius here, they're both going to be the same length. So I know the area of this triangle right here is 1/2 times 6 times 6. 1/2 the base times the height. 6 times 6. All right, let's simplify this a bit. 90 over 360 is 1/4. And 6 squared is 36, so this is 36 pi. Now for the area of the triangle, 6 times 6 is 36, and half of that is 18. Now we can simplify this a little bit more. 1/4 of 36 pi is 9 pi. So this is really 9 pi minus 18, and that's as much as we can simplify it while keeping it in terms of pi. So this is 9 pi minus 18 centimeters squared. There's your exact area in terms of pi. And again, if you want a rounded answer, put this in your calculator, use your pi button for pi. You end up getting about 10.3 centimeters squared. All right, so there's your two answers for the area of the segment of the circle. Okay, so you'll notice you're going to need to use your circle area formula. You're going to have to go step by step, work carefully with pi and simplifying things down to get your answers in terms of pi. All right, hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math and I will see you next time.